Okay, so the key takeaway is that most metals can react with acids to varying degrees. We already mentioned in the last lesson that metals tend to lose their valence electrons more easily than non-metals because of having lower ionisation energies compared to something like non-metals. And the loss of electrons is called oxidation. Corrosion is when some metals react with gases in the atmosphere, and that's a form of oxidation. And when we looked at the rusty ship before, that's an example of rust, which is a particular type of corrosion when iron corrodes. Here we've got a particle model, if you like, of reaction, a common reaction, which you might have seen in the classroom, where we have hydrochloric acid and magnesium. So the magnesium strip is put in the hydrochloric acid. Now, none of the atoms or ions are drawn to scale, so don't look at the size of them. But you can see that the magnesium disappears over time. This represents hydrogen gas, which is produced, and we see with our eyes, while we can't see the atoms and the molecules, we can see bubbles forming. So that is a sign, a qualitative sign of a gas, is the presence of bubbles. So what we see if we put a magnesium strip into a test tube with hydrochloric acid, we start seeing bubbles formed, and that tells us that a gas has been produced. We'll talk more about what that gas is in the next slide. So hydrochloric acid reacts with magnesium to form magnesium chloride and hydrogen, which is the gas. This here is the word equation, and here we have the balanced chemical equation. And we'll look at more of these through this lesson.